it's great to fantasize, but it's another thing when you have to put it together, when the nuts have to fit the bolts.
Like the Apollo missions to the Moon, sending human beings to Mars will mean putting people in harm's way. There are many dangers in outer space, and many things could go wrong. A serious equipment breakdown could doom the crew to their deaths. Some argue that the risk of failure is simply too high.
You know, back in the days when medieval man was looking out from Europe and thinking about exploring the world was unknown, and map makers populated their maps with dragons. We've got the same thing today. There are people who are afraid to go out into space, and they've populated their maps of the solar system with dragons. You know, we've got cosmic radiation, we've got zero gravity, we've got back contamination. But these are dragons that we can take on.
But unlike any other planet in the solar system besides Earth, Mars has all of the fundamentals needed to make this possible. Its 24-hour and 37-minute day is critical for growing plants. It has all of the elements necessary for creating building materials like plastics, metals, and glass. And it has oceans of water frozen into the soil.
If we can develop this craft of living on Mars, then Mars becomes inhabitable. Not immediately physically, but intellectually. I mean, look, what determines whether an environment is habitable or not? Is Colorado habitable? We're not naturally adapted to live in Colorado. We're tropical animals. No one could survive a single winter night here without technology, such as clothing, efficient use of fire. We invented our way into becoming people that could colonize such hostile environments.
There are two kinds of radiation astronauts must contend with in outer space: solar flares and cosmic rays. Solar flares are floods of protons that burst from the sun at irregular intervals and would be dangerous to an unshielded human crew.
We are not ready to send humans to Mars right now. We've got to know a lot more about radiation and radiation mitigation. One of the Apollo flights barely missed, like by a week, a major solar event. If it had gone off when the Apollo astronauts were on the way back and forth to the moon, they would have gotten their entire lifetime radiation dose in that one mission. And that's just one solar flare. So that's why we worry about this.
In the Mars Direct plan, Zubrin envisions a central, insulated core where a crew can retreat to while the radiation passes by. The core would be surrounded by all the provisions of the mission. This should stop any harmful dose of radiation from reaching the astronauts.
Basically, you use your pantry as your storm shelter. So a solar flare happens, the alarm bell rings, the crew goes into the storm shelter, they stay in there cramped up pretty tight for a few hours until the all clear rings and they come out. This is going to happen once, it might happen twice in the course of the mission.
The second type of radiation is cosmic rays. This constant rain of charged particles comes from interstellar space and cannot be avoided without many meters of shielding. We can experience some of this type of radiation on Earth at high altitudes. Airline pilots who spend their careers flying high in the atmosphere can receive almost as much of this radiation throughout their life as a Mars astronaut would on a 2.5-year mission.
It's a long trip. It's a 6-month trip there, a 6-month trip back. It's probably a year on the surface. That's a lot of radiation.
The best estimates are that the magnitude of that dose is not that great, perhaps 60 rem of radiation scattered over 2.5 years. Now, 60 rem of radiation delivered over a long period of time like that would not create any noticeable effects at all. It would, though it is believed, increase your statistical risk of getting cancer at some point later in your life by about 1%. Right now, if you're an average American and you do not smoke, you have a 20% chance you're going to die of cancer. This would make it 21. If you're an average American smoker, it's 40. So in fact, if you recruited the Mars crew out of smokers and sent them to Mars without their tobacco, you would be reducing their chance of getting cancer.
With the immense distance from Earth, never before experienced by a human being, with the constant dangers of outer space surrounding their small, life-sustaining craft, and with nowhere else to go, the psychological impact on a crew could be severe.
Fear is real. I mean, it would be to me abnormal for a person to not feel the fear of getting on a rocket and launching into space and going to Mars. So I think fear is a very normal thing that all astronauts, in fact, are supposed to have. And I would be afraid to fly with someone who does not have fear.
Some psychologists worry that cabin fever could set in, and the crew might literally go crazy.
The human Mars mission is a more rigorous and difficult condition than most of us experience in daily life. But it is hardly a more difficult situation than many people have endured throughout human history. We could compare the Mars crew to the crew of 19th century or prior sailing vessels, many of whom were away from home for 3 years or more than 3 years, under conditions in which they're eating extremely bad food, without any medical knowledge to support their health, commanded by brutal officers. In every respect, the crew of a human Mars mission, with the full support of mission support and the whole world cheering for them and great rewards awaiting for them in life upon their return, is in a vastly superior condition.
The Mars Direct crew will spend most of their time inside the 2-story HAB, carefully designed to promote psychological well-being despite the confinement.
The space where I think everybody would spend the most time, just like a lot of homes on Earth, would be the galley wardroom area. There would be chairs, a table, some kind of large screen for entertainment. You would have individual staterooms about 4 or 5 feet wide. The ability for them to communicate with loved ones, with colleagues on Earth, I think will be almost unlimited.
A Mars crew will need to be carefully chosen and thoroughly tested to ensure their ability to handle the extreme isolation.
Wow, what a place. What a view, isn't it, John? It's absolutely unreal.
John Young, who went to the moon, used to say that he could cover the Earth by just lifting his thumb up to it. And he says that when you go to Mars, you are going to redefine the concept of loneliness. And so it is very important that the crew be well balanced and well chosen so that they can support each other.
Whoever gets picked to go, they will have to learn to live together for 2.5 years.
If you put out a call for volunteers for the first crew to Mars, they'd be lined up coast to coast. Most people recognize what's left after you go is the good you left behind. And to take part in a venture of this character, of such a historic character, of extending the reach of the human species, this is something of immortal significance. One of the most bogus threats associated with the Mars mission is the so-called back contamination issue, which is this notion that you go to Mars and discover these virulent disease organisms that you bring back to Earth and destroy all life on Earth.
If we discover life on Mars, one fear is that our Earth biology will have no defense against possible Martian pathogens. Some argue that missions to Mars cannot be risked until we can prove Mars is free from harmful contaminants.
This is completely nonsensical. There's natural transfer of material from Mars to Earth all the time. We get around 500 kilograms of unsterilized Martian rocks landing on Earth every year, and they have been doing so for the past 3-4 billion years. And so if there were Martian organisms that could contaminate the Earth, they've already done so.
Although the prospect of Martian diseases seems remote, lawmakers have required that NASA create elaborate protocol to ensure that any extraterrestrial material stays contained. And like the Apollo astronauts, who spent 17 days in quarantine after their return from a sterile moon, a Mars crew will have to be thoroughly tested for any harmful Martian pathogens.
The probability is infinitesimally tiny. But nevertheless, this is our home planet and it's extremely important and we have to protect it.
The idea of a pathogen on Mars is clearly ridiculous because there is no megafauna or megaflora on Mars for pathogens to infect. So it is impossible to propose a credible life cycle for a Martian pathogen. The diseases that afflict us have been co-evolving with us and our ancestors and near relatives for the past 3 billion years, and they are specifically designed to live inside the habitat of the human body and to overcome its defenses, and they've been engaged in an arms race with the human defenses for those 3 billion years. This is why humans do not get diseases from distantly related species. For example, I don't know of any person who has ever contracted Dutch elm disease, and trees don't get colds.
When the first Mars lander touches down, the crew will be staring out at a new world, a place that in 4 billion years, no eyes have ever seen. The crew won't be alone. Millions of television viewers back home will be watching as the first man or woman places their footprint into the rust-colored soil. The crew will savor these moments, for here, someday, a new branch of civilization might begin, and future Martians will remember and celebrate this day.